On a late evening on March 20th, 2009, Emirates Flight 407 was scheduled for a routine journey from Melbourne, Australia to Dubai, utilizing a fully loaded Airbus A340-500. The aircraft, renowned for its reliability over long distances without the need for refueling, was expected to carry its 257 passengers and 18 crew members safely across the skies. The majority of these passengers had arrived from Orland Airport in New Zealand that day, gearing up for the 14-hour flight ahead under clear and favorable flying conditions. What began as a typical flight soon escalated into an unprecedented ordeal. The flight crew for this long haul included 4 pilots, double the standard number, to allow for adequate rest during the journey. The relief team, essential for the management of the flight during off periods, was also required to be present for both the flight and pre-flight checks, enhancing the overall safety of the operation. However, unknown to them, a grave error during the pre-departure phase would severely test their skills and decision-making abilities. As the flight preparation unfolded in the cockpit, cramped with 3 pilots and 2 ground engineers, a vital mistake was made. The first officer, possibly distracted by the congested environment and ongoing conversations, incorrectly inputted the aircraft's takeoff weight into the electronic flight bag, EFB, a device used to calculate crucial takeoff parameters. This error went unchecked, as it was passed from the first officer to the captain without the necessary verbal verification that might have caught the discrepancy. As a result, the aircraft was programmed to operate as if it was 262.5 tons lighter than its actual weight. This miscalculation set the stage for one of the most harrowing takeoff sequences in aviation history. As Flight 407 began its taxi towards runway 16, everything seemed normal until it reached the critical moment of takeoff. The pilots, following standard procedure, engaged the aircraft to reach its rotation speed, the point at which the aircraft should begin to lift off the runway. However, the aircraft responded sluggishly, and despite the first officer's attempts to initiate liftoff, the plane stubbornly remained on the ground. Recognizing the severity of the situation as they neared the end of the runway, the captain made the split-second decision to engage the takeoff/go-around toga thrust, desperately seeking the additional power needed to get airborne. The aircraft's tail struck the tarmac with tremendous force, sending sparks flying and causing significant structural damage. As the fuselage scraped against the runway, alarming red glows and the smell of burning metal filled the air, a terrifying experience for everyone aboard. Miraculously, the plane lifted off, barely clearing the runway, and began to climb, but not without consequences. Damage incurred was significant enough to prompt an immediate system alert of a tail strike, confirmed via radio by air traffic control. With the aircraft now unfit to continue to Dubai, the crew faced the immediate challenge of returning to Melbourne safely. Complicating their urgent return, the aircraft was heavily fueled for the initial long journey, far exceeding the safe landing weight. The crew had to act swiftly to reduce the weight by dumping fuel, a procedure that required precise calculations to ensure a safe landing weight upon return. Amidst this crisis, another critical issue surfaced. The impact had compromised the aircraft's structural integrity, causing depressurization. The situation was dire, necessitating an emergency declaration, PAN, which gave them landing priority. The crew circled above Port Phillip Bay, dumping approximately 80 tons of fuel to achieve the necessary weight reduction. As they prepared for descent, the crew encountered yet another alarming development, a potential fire on board, indicated by a rumbling noise followed by reports of smoke. This accelerated their landing sequence, adding to the already high stakes. Under immense pressure, the crew managed a successful emergency landing, narrowly avoiding a catastrophic outcome. Emergency services rushed to the scene, but fortunately, there was no fire, and all passengers and crew were safe. Post-incident inspections revealed severe damage to the aircraft's fuselage, necessitating extensive repairs. The investigation identified the initial data entry error and a lack of proper verification as primary causes of the incident. This event led to a comprehensive review of Emirates' pre-flight procedures, prompting changes, including the mandatory use of dual checks to prevent similar errors. The incident also spurred Airbus and other aviation authorities to enhance software and systems to better detect and alert crews to discrepancies in data entry. Emirates Flight 407 is a poignant reminder of the critical importance of accuracy and thoroughness in pre-flight preparations. The pilot's ability to handle the emergency prevented a potential disaster, illustrating the resilience and quick thinking required in aviation. The lessons learned from this incident have contributed significantly to improving safety protocols and standards across the aviation industry. Following the Emirates Flight 407 incident, there was a thorough post-incident review and scrutiny, not just by Emirates and Airbus, but but also by international aviation safety bodies. The in-depth investigation conducted by the Australian Transport Safety Bureau, ATSB, in collaboration with other aviation safety organisations, provided critical insights into the cascading sequence of events that nearly led to a catastrophe. One of the significant outcomes of the investigation was the highlighting of deficiencies in the pilot pre-flight preparation and verification processes. It became evident that the error in data entry was not just a one-off mistake by the first officer, but also a systemic failure to catch the error through standard checks. This revelation led to a broader discussion in the aviation industry about the safeguards necessary to prevent such errors, especially in the digital tools used for calculating critical flight parameters. In response to the incident, Emirates took several corrective steps to fortify their safety protocols. Recognizing that human error could be mitigated through better system design, they introduced mandatory dual checks for data entry. This required that all critical information, such as takeoff weight and speed calculations, be verified independently by 2 crew members before being finalized. This redundancy was aimed at catching discrepancies that might be overlooked by a single individual. Moreover, Emirates and Airbus both initiated enhancements to their electronic flight bag, EFB systems. These enhancements included better error detection capabilities, such as alerts for data entries that significantly deviate from standard parameters. Airbus also embarked on a project to develop more robust software that would provide real-time data verification against the aircraft's actual conditions and alert pilots to inconsistencies. The incident also prompted a broader regulatory response. The ATSB, along with the International Air Transport Association, IATA, and the Federal Aviation Administration, FAA, in the United States, issued a series of safety recommendations. These recommendations were targeted at improving pre-flight checks across the industry. They called for more rigorous training for cockpit crews on the importance of data verification and the potential consequences of errors. Additionally, they suggested enhancements to pilot training programs, emphasizing scenario-based training that includes handling unexpected events and system failures during critical phases of flight. The repair of the damaged Airbus A340 was another aspect of the aftermath. The aircraft underwent extensive repairs to fix the structural damage to its fuselage and systems. After a meticulous examination and restoration, it was returned to service, continuing to operate for Emirates until its retirement in 2014. The repair process itself served as a case study for aerospace engineering professionals in handling severe impact damage and understanding the resilience of aircraft structures. Reflecting on the incident, the aviation community recognized the critical importance of resilience in safety systems. Resilience not just in terms of structural integrity of aircraft, but also in the procedural and human factors aspects of aviation operations. The incident reinforced the need for a holistic approach to safety, combining technology, training, and strict procedural adherence to prevent similar incidents in the future. As we discuss the implications of this incident, it's crucial to consider how such lessons can be universally applied to enhance safety standards globally. The quick response and effective decision-making by the flight crew of Flight 407 under extreme stress were commendable, but the incident underscores the need for constant vigilance and continuous improvement in safety practices. What are your views on the changes implemented following this near miss? Do you think the aviation industry is doing enough to leverage technology to enhance safety? Share your thoughts and join the conversation as we delve deeper into the ever-evolving world of aviation safety.